everyone, welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem 3130. Find all possible stable binary arrays 2. You are given three positive integers 0, 1 and limit. Okay. A binary array ARR is stable if the number of consecutive zeros in ARR is exactly 0. The number of occurrences of ones in ARR is exactly 1. Each subarray of ARR with size greater than limit must contain both zeros and ones. Okay, if all these three criteria holds true for a for a particular array, then we can say it as a stable array. Okay, return the number of stable binary arrays, total number of stable binary arrays. Okay, if you look at the example, I have three zeros over here and three ones available with me and limit is 2. Okay, that means if I choose any subarray of a if I choose any subarray whose length is greater than 2, it should contain both zeros and ones in it. Okay, so if I choose a subarray of size 3, okay, it contains both zeros and ones in it. Okay, no matter which subarray you choose, every subarray will contain both ones and zeros in it, and it also contains three zeros and three ones. So this is a valid binary stable binary array. Okay, so if you clearly observe, the limit is 2 and the occurrences of 0 is the consecutive occurrence of 0 is not exceeding the limit. Okay, that is one key observation which you have to derive from the problem statement. Okay, so let's say we have a magical function f which will take these three parameters. Okay, which will take 0 as a parameter, number of zeros which we have and the number of ones which we have, and since we have to form stable array, okay, stable arrays, the stable arrays can either end with 1 or it can either end with 0. Okay, right, it can either end with 1 or end with 0. Okay, now the total number of stable arrays will be the summation of the stable arrays which are ending with 0 and the stable arrays which are ending with 1, right? So let's consider the stable arrays which are ending with 1 for time being. Okay, so I have to count the number of stable arrays which are ending with 1. Okay, since I've freezed my last position with 1, then the total number of available ones for the rest of my array will reduce by 1. Okay, so I have, now that I have freezed my last position, the available ones were reduced by 1. Okay, so for the rest of the subarray I have to form, okay, for the rest of my subarray, okay, for the rest of my subarray I have to form stable array. I need to know how many stable arrays I can form. Okay, now again this stable array can also end with zeros or ones. Okay, so answer to this I can be written as answer with stable arrays ending with 0 and, okay, so we don't know these positions. Okay, so since we have freezed the last position, so answer to the rest of the array can be derived as answer, it, it can be end with 0 or it can also end with 1, right? I hope you guys are following. Okay, so since I have freezed the last position, okay, since I have freezed the last position, I need to identify the number of stable subarrays I can form for the rest, right? Now the rest of the subarray can also end with 0 or can also end with 1, right? So let's, these answers from this will also contribute to my overall answer, and answer to this will also contribute to my overall answer, right? Now if you choose to end with ones, okay, now these answers are, okay, the stable arrays which can be formed can be categorized into two things. Okay, one is the number of ones which I have, okay, the number of ones which I have is less than limit, and the other criteria, other situation is the number of ones is exactly equal to limit, right? This solution contains both of this, right? We have defined our state as at any given point we are identifying the stable arrays, right? So the number of stable arrays which can be formed from this will contain the continuous zeros, which the number of zeros is exactly less than limit and the continuous zeros is equal to limit. Okay, if we also consider the continuous ones which is exactly equal to limit, then adding 1 to it will result a unstable array. That means this contains both of the solutions. I have to subtract the solutions which are contributing to this. So what I will do, I will identify the number of stables arrays whose which have the last characters as exactly equal to the limit of 1. Okay, so if what I'm doing is I was defining the last limit number of characters as 1, I'm fixing this. Okay, because I have to eliminate all these answers. Okay, this answer is, if you see, I can write this as basically all the characters ending with 0. I hope you already got it. Okay, so I have to just subtract these the answers to the subarrays which have the last characters equal to the limit times ones. Okay, so since the number of ones here are limit and I also freeze the last character as also 1, so I have to find the answer for the rest of this problem. I have to find the answer to the rest of the problem with ending with 0, right? It has to end with 0, right? So if you see, I can write whatever I've explained, I have written that in terms of the recursive relation. Okay, so given a function f which has these many zeros and these many ones in it, and L is basically the last character or the last position value in the array. Okay, if the last position is 1, okay, if the last position is 1, then my answer can be derived from two sub answers, right? Two sub problems. The first sub problem is, since the last character has been freezed with 1, I have to form the rest of the sub array with 0 minus 1 ones and z ones in it, and it can end with 0 or it can end with 1, right? It can end with 0 or it can end with 1. So this is what we have. Since this also contains ending with limit 1 or less, okay, ending with ones which is exactly equal to limit or lesser, so we have to exclude the answer where it is ending with exactly ones with equal to limit. So that can be derived from this, right? F of z minus 0 minus limit minus 1, where 1 is the position which we have freezed for the last position, and these were the limit number of ones which we have. So the total number of available ones I have after freezing all these positions is basically O minus limit minus 1, right? The similar case will be if the last character is 0. Again, if the last character is 0, that means the last but one character can be either 1 or can be either 0, right? Again, the last but one character, if it is 0, then it can also have the limit number of zeros ending in this as well. So I have to exclude those answers. So that is what I have done here, right? Now that you have derived the recursive relation, you should also derive the base cases, right? If the number of available zeros are less than 0 or the ones are less than 0, then straight away answer will be 0, right? If z is 0, okay, whenever z is 0, then if the available ones are less than limit, and if the last position is 1, then it can be contributed as 1. Okay, if you think in the vice versa, if I have ones greater than the limit, that means the subarray which I will be choosing will not contain zeros in it. So that is the reason we will be contributing the other cases as 0, and these cases as a valid answer, right? So coming up with base cases is pretty tricky. You have to think about these base cases. Okay, so once we have written our recursive relation, right, it is pretty straightforward to convert this into the code and memorizing it, right? So if you're following my DP series, you should be able to write the code straight away with this recursive relation, and you can memorize it. uh, Anyhow, I will be showing the solution as well. Okay, now that you know z, the total number of unique states I have is basically the last position have two possible values, and z o can go from 0 till all the way to the number of ones, and z is also will go from 0 all the way up to the number of zeros. So those many unique states we have, and I'm filling all the states with -1, indicating that answer to all these states is not calculated. And then I've just defined a global variable in my class and set the limit value to it. Now that my overall answer will be coming from two sub problems, either it can end with 0 or either it can end with 1, right? And then I'm taking modulo overall. Okay, now I've just defined, I've just converted this into the function. If you see, if z is equal to 0, then this case is basically the similar case I have over here. And if 0 is o is basically 0, that means the number of ones I have is basically 0. Then if the number of zeros is less than or equal to limit, and if the last position is 0, then it will be contributed as a valid solution, or else we will be contributing it as a 0. Okay, if answer to a particular state is already calculated, then we'll be returning the state, or else we'll go ahead and compute the answer. Okay, if the last position is 0, then the last but one position can be 0 or can be 1, and since we are freezing the last position with 0, then the number of available zeros will be reduced by 1, right? Now there is also possibility, as I mentioned, there is also possibility that this solution will contain the limit number of zeros at the end, which I have to subtract. So I'm just deriving the answer for z minus limit -1, which are ending with one position, 1 in the last position. And then this is the scenario when last position is 0. If the last position is 1, this is how the recursive relation will look like. In the end, I am taking module and I am returning it. Okay, if you submit this, all the test cases will be passed and it will be pretty efficient solution as well. Okay, if before analyzing the time and space complexity, I highly recommend you to subscribe to my coding channel so that you won't be missing the content which I will be posting on daily basis. I've also started dynamic programming study plan playlist where I've solved all the dynamic programming problems from the Leetcode study plan. Okay, I will be posting solution to this problem in multiple languages such as Java, JavaScript and Python. If you're coming from any other languages, feel free to check it out. Thank you.